In this class, we will try to understand about dipole and dipole moment. You will understand dipole and dipole moment. So first of all, I would like to tell you what is actually dipole. What is dipole? Okay. So dipole is simply di means two. This di means two and pole means charge. Okay, so the dipole means two charges, or we can define it like the combination of two equal and unlike charges. What is the meaning of unlike? Unlike means one is positive and other one is negative, and magnitude should be equal. So if we talk about one charge is plus q and other is minus q, and if these two charges are kept at some distance, that is minus q is placed here and plus q is placed here, then this combination is called the dipole. What is called? Dipole means, so, or in simple word we can define, if two equal and unlike charges are kept at small distance, then this combination is called dipole. Clear? So it is simply the combination of two equal and unlike charges. The separation between these charges is considered as 2a. Somewhere it is written as 2l. You can take anything, whatever you like. Okay, so this is the dipole. Now the topic is to understand electric field due to this dipole. The topic is electric field intensity due to dipole. Electric field intensity due to dipole. So electric field intensity due to dipole can be calculated at 3 points. 3 cases may be there. How many cases? 3 cases may be there. First case, on axial point. It is also known as end-on position. What is it called? End-on position. Second is the equatorial point. That is called the broad side on position. Right? And third one is arbitrary point. So it is simply one axial point, other one is equatorial point, and third one is arbitrary point. Arbitrary point means the point which is neither on equator nor on axial. So diagrammatically, first we understand the axial point. What will understand? Axial point. I am not talking about the intensity now, but the axial point. If we talk about the dipoles, if one dipole is there, A point is here plus Q charge is placed, and other point B is here, and minus q charge is placed. The separation between these charges is 2a. Okay, so this will call this whole point will call the x, that side also. So any point on this line, what the point, any point on this line on either side of the dipole, either here or here, means either from A to outside or from B to outside, any point on this line is called the axial point. Means if we are talking about like axial point, so this point can be axial point, this point, this point, this point can be axial, this point can be axial, and this one can also be axial. Okay, so axial point means we are talking about this point, any point of those. The midpoint of the dipole is considered as O. So since it is midpoint, so this will be A, this will also be A. This is simply the diagram of axial point. If we talk about the equatorial point, so wait, I'm telling you. The equatorial point. Equatorial point, right? So it's the equatorial point. Now equatorial point is what? If dipole is plus q A minus q B. So equatorial point means the point which is on the equator of this line. Means if we talk about the dipole, this AB, then equator will be, this is midpoint. So any point on this line or that line, means the perpendicular bisector of this dipole, the any point on the perpendicular bisector of this dipole is called the equatorial point. Means any point here, 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 anywhere is the equatorial point. Okay, now third point was arbitrary point. What was it? Arbitrary point. So what is the meaning of arbitrary point? Arbitrary point means dipole is plus q A here and minus q B here, then any point except axis or equator. Means the point should not be on axial axis of the dipole or on the equator of the dipole. That means point can be here, 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 anywhere, anywhere, or that side anywhere, that side anywhere, that side anywhere. Mean except the points on this line and this line. These all points will be equatorial and these all points will be axial. These will also be axial point. Okay, now our task is to find the electric field intensity due to dipole on axial point. First we talk about the axial point. So intensity of electric field due to dipole on axial point. Okay, so first of all we need to understand, we first draw the diagram. This is A plus q charge is here, other one is B minus q charge is here. We are talking about axial point, so this will be the axis of the dipole. Okay, so suppose the point is here P. Okay, this is the point where we need to observe the electric field intensity. This is the point O, midpoint of the dipole. This will be A, this will be B, sorry, this is will also be A, and this O. Let the point P is at the distance r from the center of the dipole. Keep in mind that this r always distance from the center of dipole, always in any case, means in axial case, in equatorial case, or in arbitrary case, this distance would be from the center of the dipole. Now we are talking about this. So first of all, we should know what is the formula for the electric field intensity. See, electric field E, it's a vector quantity, okay, and dipole is the combination of two charges, plus q and minus q. If we are trying to find the electric field intensity due to dipole, that means what? We simply find the electric field intensity due to this plus q charge and due to this minus q charge at point P, and we will add them vectorially. Remember, we will add them vectorially because electric field is a vector quantity. So let E1 is the electric field intensity due to dipole, not the dipole, due to plus q charge at point P, and E2 is same, is electric field intensity due to dipole, not dipole again, sorry, due to minus q charge at P. Then electric field intensity due to dipole will AB, the name of the dipole is AB, will be equal to E1 vector plus E2 vector. Clear? If we are considering that plus due electric field intensity due to plus q charge at point P is E1 and due to minus q charge at P is E2, then this dipole is the combination of these two. So the electric field intensity due to this dipole will be equal to the sum of the electric field intensity due to these individual charges. I'm sure it's clear to you. Since it is a vector quantity, that's why I'm adding them vectorially. Don't forget to put the vector on E1 and E2. Now we will find the electric field intensity due to first plus q and then minus q at point P. So first, electric field intensity due to plus q charge, that means plus q charge. So we have from the electric field due to point charge, what is it? E is equal to 1 upon 4 by epsilon naught q by r square, where everything is, 4 by epsilon naught is a constant, it's 9 into 10 raised to power 9, and q is the charge, and since it is a vector quantity, so the direction is always where? Away from positive and towards negative. The direction of E is always away from positive. Clear? You'll clearly understand the direction. Okay, so now for our case, here this A P is the dipole, plus Q charge is here, and point P is here. So we will find what is our task. We need to find E. For this we need to know the value of Q and the value of R. Listen carefully, it's very important, and I'm sure it's very easy, but you need to understand few small things. E is equal to 1 upon 4 pi epsilon. This is whole, this is constant. What it is? Constant. So we do not need to bother about this, except this. What is it here? Q and R. So we need to understand what is Q, and secondly we need to understand what is R. R is what? Distance of the point of observation from the source charge. This is called the source charge, right? So in our case, R is what? AP, isn't it? A to P. Clear? This is the point. This point is P. So from A to P, and that is also equal to from here to here plus here to here. That means from A to O plus O to P. That can also be written as AO is what? Small a, and what is OP? That is R. Got the point? Fine. So for this, therefore E1, that means what? Electric field intensity due to plus Q charge at point P. Electric field intensity due to plus Q charge at point P. E1 is equal to 1 upon 4 pi epsilon naught as it is, into Q is what? Plus Q, upon R is what? R plus A the whole of square. Clear? I'm sure no doubts will be there. And direction is very important. So direction will be positive charge is there. So away from positive, that means A to P. I'm repeating again. E1 1 upon 4 pi epsilon naught as it is, Q plus Q, R, that is A plus R or R plus A can be written as. So this is the equation number 1. Now we will find the same for the minus Q charge. So for E2 1 upon 4 pi epsilon naught. For E2 1 upon 4 pi epsilon naught, charge is minus Q, and R is what? Let me tell you. What is R for this charge? R will be BP. What will be? It will be BP the whole of square. Now what is BP? BP is equal to, check it, BP. So it is, whole is R, and in this A will be minus. Since we are talking about from B to P, so it will be OP minus OB. So it will be OP minus OB, that is R minus A. It will be OP minus OB, that is R minus A. So we will write E2 is equal to 1 upon 4 pi epsilon naught minus Q upon R minus A the whole of square. Since it's a negative, so that means direction will be away from positive and towards negative. So that towards negative means the direction will be from P to B. So the direction will be from P to B. Now what is the task? So total E will be equal to vector E1 plus vector E2 along with the direction. So it will be 1 upon 4 pi epsilon naught as it is, plus Q as it is, R plus A the whole of square as it is, plus we are adding the two vectors. So 1 upon 4 pi epsilon naught as it is, minus Q upon R minus A the whole of square. Now you'll say that why I am not counting the direction here. So we have taken AP as positive. Then the direction BP, check it. AP is from left to right and PB is from right to left. So they are in opposite direction. That means they will get subtract. That's why the negative charge is here. Either you can write PB or AP, so it will subtract, or you can simply write plus Q and minus Q. So they will subtract 1 upon 4 pi epsilon naught Q common 1 upon R plus A the whole of square minus 1 upon R minus A the whole of square. So it is Q upon 4 pi epsilon naught R square plus A square minus 2 R A. Open this and left side plus minus bracket R square plus A square plus 2 R A. Bracket close, and in denominator the powers will be R plus A the whole of square, R minus A the whole of square. Clear? So open this bracket, minus will get inside, minus minus, this will cancel with this will cancel with this, and this is negative, this is negative, so it will become Q upon 4 pi epsilon naught minus 2RA, that is minus 4RA upon A plus B, A minus B, right? So it will be A square minus B square, and whole square is there, so it will be whole square. Again R A plus B, A minus B, that is A square minus B square, and whole square is there, so you can write whole of square. Negative sign simply shows that direction is according to the negative, this one, so the direction will be from P to B. This negative is showing the same thing, so the direction will be from P to B. So E is equal to 1 upon 4 pi epsilon naught Q. 4 can be split into two parts, 2A into 2R upon R square minus A square the whole of square. Okay, this 2QA is the dipole moment, you are quite aware of this. So 1 upon 4 pi epsilon naught 2PR upon R square minus A square the whole of square. This is E. This is the formula for the electric field intensity due to dipole on axial point. Some special cases also there. If we consider A is very small, then it will be, and if we consider that A is quite large, then something may be there. I am writing the same. So the formula is E is equal to 1 upon 4 pi epsilon naught 2PR upon R square minus A square the whole of square. Okay, so if A is very less as compared to R, then A square can be ignored, so it can be written as E is equal to 1 upon 4 pi epsilon naught 2PR upon R power 4. So it can be cancelled out, that is equal, this implies E is equal to 1 upon 4 pi epsilon naught 2P by R cube. This is the formula for the electric field intensity due to dipole, and direction will be from towards negative charge. Where? Towards negative. Okay, this is the electric field intensity due to dipole on axial point. Now equatorial, if you are able to understand axial, then equatorial is quite easy. E due to dipole on equatorial point. So in equatorial point, what is there in equatorial point? 1 plus q charge is here, other minus q charge is here. This dipole is A, B, this is the midpoint, and suppose the point P is here, the equatorial point. It will be at a distance r. As I told you, the distance r is always from the center of the dipole, and A, P is here, and we will join this also. So as an electric field due to dipole on axial point, similarly we will solve it for the equatorial point. First we will find the electric field due to plus q charge at this point, and we will find the electric field due to minus q charge at this point, and we will then vectorially add them. Before going to this, we need to know what is the value of AP. Whatever the value of AP, so the same value will be of BP. So this AP can be found by using the Pythagoras theorem. AP square will be equal to AO square plus OP square. That is, AO is what? AO is A square, and OP is what? This is R square. So AP is equal to square root of A square plus R square, or it is can also be written as A square plus R square power 1 by 2. Similarly, it will be BP, right? So now from the definition, E is equal to 1 upon 4 pi epsilon naught Q by R square, and here for plus Q charge, electric field at point P, E1 is equal to 1 upon 4 pi epsilon naught plus Q upon AP the whole of square, that is equal to 1 upon 4 pi epsilon naught. AP is what? Q by R square plus A square power 1 by 2, and the formula is whole of square. And out. Clear now? Okay. Then it will be 1 upon 4 pi epsilon naught Q by R square plus A square. This 2 will cancel with this 2. E. And the direction will be from A to P. Direction is from A to P. This is the equation first. Similarly, E2 is equal to 1 upon 4 pi epsilon naught minus Q upon, distance will be the same, A square plus R square power nothing, and the direction will be from, since it's negative, so away from positive and towards negative, so direction for this will be here, and for this will be, it will be from P to B. This is the twist here about the direction. This is the twist. So E1 will be here and E2 will be here. Remember, these are the vector quantities. Suppose this angle is theta. Suppose. So this will also be theta. If we draw one parallel line with the base, so this will also be theta. This will also be theta. Okay. What will we do now? We will resolve the electric field E1 and E2 in two components. So one component of this E1 will be here, E1 cos theta, and other component will be here, that is E1 sine theta. Clear? So E1 cos theta along that direction and E1 sine theta along this direction. Similarly for E2, what will be here? It will be E2 cos theta in this direction and E2 sine theta in vertical downward direction. Again I am repeating, E1 component, E1 cos theta along this and E1 sine theta along this. In 11th standard you are quite aware of this vector resolution. And for E2 cos theta will be along that direction and sine theta will be along that direction. And also we know that magnitude of E1 is equal to magnitude of E2. From here you can see the magnitude is same. So the sine component of these two will cancel. What will happen? So the sine component of these two will cancel. So what will left with us will be net E will be equal to E1 cos theta plus E2 cos theta along with magnitude. Okay, so E1 is equal to E2, so it will be 2E cos theta. That can also be written as 2E is what? E is 1 upon 4 by epsilon naught Q by R square plus A square. And now come to the cos theta. So what will be the value of cos theta? Cos theta can be found from here. This is theta, this is base, this theta, so base will be this, hypotenuse will be this. So cos theta will be equal to base upon hypotenuse, that is under root R square plus A square. So here cos theta will be equal to A upon under root R square plus A square. From this is the power 1 and this is the power half. Multiplication is there, so we will add the power. What will we do? We will add the power. 1 plus 1 by 2, that will give you the power 3 by 2. So that is 1 upon 4 by epsilon naught 2QA, that is P, and R square plus A square whole power R square plus A square power 3 by 2. And direction is where? Direction can be understand from here, parallel to the axis of the dipole from positive to negative. Direction will be parallel to the dipole. You can understand from here, parallel to the dipole and from plus q to minus q charge. So that's all in this. You again, I am emphasizing on that part that the value 3 by 2 comes, that this is 1 and this one is 1 by 2, which comes after replacing this cos theta by using this triangle. So the power will be R square plus A square power 3 by 2. Thank you very much. I hope you will love this all, and God bless you all. Thank you.